Java requires that variables have to be declared before they can be used. So these are examples of variable declarations. So these are also examples of variable declarations right here. I'll just copy and paste this new example into my sample program. And when I paste this in, I often just use source format to bring it to the default white space indentation, and they begin to look quite nice. So here, this sign, equal sign, represents initial value assignment to the variable that is just being created. We call this initializer. So it's a good idea to provide initializer to your variables. Then when we start using the variables, once again I just copy and paste and use source format to bring everything to a nicely formatted view. So here we initialize quantity with 0, and then we decided to change its value to 10. And later on, we want to change it from 10 to whatever this other variable contains, like 100. So in this instance, we use the same punctuation, the equal sign, but this equal sign is actually an assignment operator. It takes the expression on the right-hand side, computes it, if there's more computation to be done, and assigns it to the left-hand side. So this has to be the name of the variable that can accept this new value. So this is an example of an assignment operator from right to left. So the direction of assignment is this. This is the direction of the assignment. We go from right to left. We already named the variable naming convention. Once again, start with the lowercase letter when you're working with your local variables, and use uppercase or capitalize it with the next noun or word that you make the whole name from. So here we have this uppercase character right here, capitalized, maximum quantity. Arithmetic operators are additions, subtractions, multiplications, and divisions. And so they correspond to these specific operators right here. So we can, you can see here that these are all pretty simple ideas right here. But there is one interesting aspect of this. Let's take these two variable declarations of x and y, and also this last statement right here. Once again, I'd like to just go ahead and say source format to keep it all nice. Sometimes the comments are misaligned, but it's easy to bring them back in order. So here we have a 14 divided by 8, right? So because we say let's divide x by y. So the numeric value of 8 fits inside 14 only once, and then the rest of it, like 6, is the remainder. So the result of this division, because x and y are integers, this is an integer division and not a conventional real number division, which would give you some kind of fractional result. So the result of this is another integer, and the idea is that 14 divided by 8 is 1 with the remainder 6, and remainder 6 is thrown away. So the result is 1. Right? So the result for variable is assigned the value of 1 as a result of this integer division. With the double type, of course, what we get is the behavior changes so that the results become fractional results as expected. So if you are only using integer rules for integer arithmetic, you could use integers. If you think that you may be needing to use the real numbers, then of course you need to switch your data type to a double to do your computations. And sometimes you need to mix them. Sometimes you want to take an integer and mix this integer with another computation. So in other words, if I want this result 4 to be a double, in order for me to do something like this, I will add an output statement like this. And print result 4, which is the name of the variable. So here, if I run this code, just save everything, run, which builds it and runs it, you see that the outcome is 1.0. So if this is not what you want, because what just happened, we took two integer numbers and divided them, and the integer arithmetic was applied. But if you need to obtain the true floating point result from here, and if you want the true result, you have two choices. You could change the type of one of the variables to be a double, and then if I run this version of my program, you see that it prints the real number result. Or I could just keep it an int and tell the compiler that I want to use this expression not as an integer division expression, but rather a floating point division. So I can tell the compiler that I want to change the type of this variable inside this computation to a double type. In other words, promote integer to a double. We like to say promote because integer is only 4 bytes and double is a bigger data type. So anyway, this is called casting, the data type casting in Java. And so both x and y remain integers, but the result should be, as expected, 1.75. I also would like to demonstrate something else here. For instance, if you make a syntax error and you type it incorrectly like this. This is an incorrect syntax, and I do this intentionally. And if I just ignore this and I casually say, just do it for me, you see that this dialog box shows up right here. It says one or more projects were compiled with errors. Application you are running may end unexpectedly. And it gives you a choice to run anyway. I would suggest that there is absolutely no reason, I just cannot see a good reason to do something like this, because if I say run anyway, it will probably attempt to use some results from a prior build that was able to complete correctly without errors. And anyway, so this should be a huge stop sign for you and say stop, just cancel. And you see that it gives me some sort of other message here, build failed, and it's all not in any way clear to me what is happening. It's also possible that I'm not seeing this error message, that it's hidden somewhere. So there's absolutely unacceptable situation, I think. So this is why when I see something like this dialog box that appears like this, I cancel. And if I am not sure what is happening, I immediately proceed here to the name of my project, right click and say clean and build. This way it will show you all of the error messages like this, and you see that although I intentionally hide this from my view, I can click again. I would just locate the very first error message, ignore, most of the time I just ignore any subsequent error messages that are simply the results of the first error message, and I click on this link, which gives you a jump directly to where this error is, and it even places the cursor right next to the incorrect syntax, right? So this is something that you need to realize, and it just tells me that something else was expected, you know, it's an illegal start of expression, so it's just really bad expression syntax, right? So in reality, once again, I need to be able to recognize this and replace it with the syntax that was here originally, which is a casting from an integer, because integer x was declared as an integer, and making it a double, and therefore once one of the operands of this division is promoted to a double, the rest of the expression will use the rules for double for computation. So once again, with this result, I don't get any weird error messages or any boxes, and here it just prints 175. So this does compute the fractional parts correctly. So just a few notes about mixing integers and doubles. As we're still seeing this example, although in tutorials and sometimes in textbooks a single character variable names are used, I would say that in real applications it is unacceptable to use a single character variable names. They're simply too undescriptive and pretty vague in terms of the understanding. Right here it's just confusing. Does x and y represent coordinates somewhere on some kind of 2D plane? Is this just random values that represent some kind of integers? It's not clear at all what is the meaning of these two variables. Quite a huge contrast compared to quantity and maximum quantity. So just be aware that sometimes you copy and paste examples, and it's okay in a little program like this to examine how it all works. But in a real application, naming variables x and y or ABC, just a single character name, is totally unacceptable.